So today we will be talking about introduction to data structures. What are data structures? A data structure determines how data is organized so that information can be used efficiently. Each data structure supports some operations efficiently, while other operations are either inefficient or not supported at all. Since different operations are supported by each data structure, you should carefully evaluate which data structure will work best for your particular problem. For example, in C++, we have many different data structures, but there are two main ones. There's a stack, and there's a queue. A stack, like in real life, is a stack of dishes, let's suppose. This is a dish, and there's a dish underneath, and here, and here. This is our stack. So, if we want to add an element, so let's suppose this is our table, we can either have a plate right here and give it to the top. This is one operation. So put plate, let's say, put plate. So we put the plate to the top of the stack. So we do not put the plate to the bottom or to the middle. We do not do this. We just put it to the top. Because in real life, it would be very costly to put it into the middle. We would have to erase this plate, and only then we could call the put plate method and put the plate and put the rest of the plates. So this is our one operation of our stack. The second operation of our stack is, of course, getting a plate. So get plate. We cannot get the plate from the bottom. We cannot get it from the middle. We just can get it from the top. Okay. So now let's go to the next example. Let's erase this first, and let's go to the queue. So the queue is data structure like in normal or real life. We have, let's say, a queue of people. This is the first person in the queue. This is the second person of the queue. This is the third. And then we have the fourth. The first operation, we can go into the queue. This is our person. Let's say we. So me. And I want to go into the queue. So there's a method go into, just like this. Go into. We cannot go into the middle because other people will be angry, or to the front. We just can go to the last position. On the other hand, if we are, let's say, this man right here, okay, we can get out of the queue like this. We cannot, let's say, this man cannot this man cannot go out from the queue so easily, but this man right here, so this man cannot, this man can, because he's the first one. So go out. So these are the two operations supported by the queue. I think that you can see some similarities between the queue and the stack. First of all, let's showcase them both next to each other. So this is the stack right here, and here are our plates or just elements, and here is our queue. like this. So a stack can go in and go out from the top, but a queue can go in but go out in different positions. So like we said, so since different operations are supported by each data structure, we say that each data structure supports some different operations efficiently while others inefficiently. And some operations we do not support, and let's suppose a queue or a stack. So our queue does not support like popping from this right here, cannot do such a thing like a queue. On the other hand, the stack, cannot pop the element from this or in the middle like a queue. Let's go to the next slide. Okay. STO data structures. The C++ standard library data structures are designed to store any type of data. We put the desired type of data within the brackets when declaring the data structure. So, for example, like in the previous slide, I showed you what a stack is. So in C++, we declare it like stack, lower letter in the beginning, and we put an opening bracket, a type right here of our data structure. So our plates will go here, and a closing bracket. This type can be a variety of different types. So it can be an integer, it can be a character, it can be a short. So let's see some examples of that. A stack of an integer is written like this, a stack of an integer. Then a stack of a char is written like this, stack of a char, sorry, character, like this. And the last one is a stack of a short. So it's like a short integer. Of course, we will go into more detail in the next examples. Nearly every standard library data structure supports the size method, which returns the number of elements in the data structure, and the empty method, which returns true if the data structure is empty and false otherwise. So now let's go to the queue data structure. We know that we can define a queue like a stack, like this queue of ints. Okay, this is our queue of ints, and this queue and nearly every other data structure in the C++ standard library support the size and the empty method. So let's suppose we name our queue like just queue. So QQ, this is our name of our queue. This is our name, queue. And we want to know the size of our queue. So we made some operations right here, some operations on the queue. And now we want to know the number of elements, or otherwise the size of our queue. We call just queue, not this queue, but the name, dot size and brackets and semicolon like in C++. So this is the notation, and this will give us the size of our queue. Sorry, not G, queue. And that is called queue, of course. That is called queue, or its name is queue, or any other way. But let's suppose that we no longer want elements in our queue, so we want to empty our queue. This can be done very easily in any data structure also. It can be done with just doing queue, the name of course, dot empty, and parentheses like this. Queue.empty, and now our queue is like this, so there's no people or elements inside, there's no people. So this can be like this. Okay. Now let's go to some examples. First of all, let's explain ourselves what are arrays. I will explain you arrays in some code. So first of all, how we initialize, define an array. So C++ is very easy. We just type array, and like in the previous examples, we define the type right in here. So I want an array of type int, and let's call it ARR, so a short for array. Now we initialize an array of ints, so I'll just comment array of ints. So an array is a pretty easy data structure. It stores its element in a continuous manner. So for example, this is our big memory. This is our memory. And some data structures, not the array, have like an element here, an element here, an element here, and they like link to each other so they know where they are. But an array is simpler than this. An array just occupies one chunk of our memory. So this, let's suppose, is our chunk of memory that our array occupies. So we see that it is contiguous. So every element is this is index 1, 2, 3, 4, 5. They're continuous. So this is after this, this is after this, this is after this, this, and this. We do not have like the index 0 is right here. Then let's suppose there's a 1 here, so there's a link. We don't have this in the implementation of the array in C++. We just have some continuous block of memory just to store our array. If we will be learning dynamic arrays, or otherwise called in C++ a vector. This is a very popular dynamic array in C++. I will just tell you a tip that arrays are just a little bit faster, not noticeably much, but just a little bit faster than vectors. So I will write it down right here. So they are a little, or let's a tiny bit faster than vector. Other is called dynamic arrays. So an array is not perfect. We need to have a size of our array, because we allocate a certain memory right here. We need to know how much we want to allocate. So with this in mind, we need to pass another argument to our array initialization, and it will be array int, like here, but you pass another argument, the size of our array. So let's suppose I want 5 elements, and I'll close the bracket and write ARR. So this is the difference, because we want to allocate some memory. We need to know that our chunk memory will have a length or size of 5. This isn't particularly the length of 5. This is more like a length of 6, but it's just for the example. So let's fix our code. Let's erase this first, and let's fix our code. So let's write array of int of 5 elements. Array. Okay. And let's say this is the actual proper way of initializing. Okay, the first one was just for show, in you to know that we pass one argument, an integer or the type. So here is the type. Okay. Now, how do we calculate this value, this 5? Can it be like, let's suppose, let's write some code right here. This is an example. Let's write like this example, and we'll have, let's suppose, an integer n will be 5. Okay, and we want to have an array of size integer and size n. Okay, so I have a question for you. Do you think that if we have just a normal integer n, so it's not a constant, not a constant expression, not nothing, just a regular variable, can we pass it as our value to our size of the array? Well, actually we cannot. Why? Because n is not constant or a constant expression. Even a constant is not allowed in here, only a constant expression. So only a constant expression is allowed here. Nothing else, nothing more, only a constant expression. So n is not allowed because it's not constant. So you must look out for this. But if you want to change our code to allow n to be right here, we can just do a couple things. Let's first erase this and let's change our code. So if we want to make this happen, let's say this is example number 1 and this is example number 2. Example number 2, we will have to have a constant expression int n is equal to 5, and then we can initialize our array with an n. This is actually possible. This right here. This is allowed because here we have a constant expression. Usually in contest or Usaco problems or anything like that, we just use a constant like here. Just a 5, but it's pretty large, so in a normal competitive environment we'll have like 10 to the power of 6 as our constant. Perhaps surprisingly, the std array is an aggregate. This means it has no constructs and instead is initialized using aggregate initialization. As a quick recap, aggregate initialization allows us to directly initialize the numbers of aggregates. To do this, we provide initializer list, which is a brace enclosed list of comma-separated initialization values. So for example, we can initialize our list or array like this. So we can have an, for example, let's do it here. Example 3, and you have also a const express, or just use a professional array. array integer, or let's say 189. So it's 10 to the power of 9 array, and we pass an initializer list, and we can pass as many values as we want, but you must be careful, because if, for example, you pass, for example, you have some number of, let's erase this first for my explanation. Alright, and now let's suppose that this right here is the number, I call it hashtag, the number of elements passed to our array. So right here we will have 1, 2, 3, 4 elements. 4 elements right here. Okay. And we have two ways of doing things, or rather the interpreter doing things. If we pass too little or too much. So if you pass too little, what does it mean? First of all, well, how do we pass too little elements? Let's see that here we will have 10 to the power of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the size of our whole array. Alright? And we just passed 4 elements. Just 4. So the rest, the 9 with 9996 something, will be initialized with zeros. The rest, rest will be zeros. Alright. But what will happen if we pass too much elements right here? Well, we will just have an error. Because if you want to have, let's suppose, an array of 3 elements, alright, we know that our memory will have only 3 cells available. And if we want to pass, let's say, 5 right here, 6 right here, 7 right here, and here we want to pass an 8 or even a 9, it's not possible to assign these two values. You'll have these two values out of bounds, and this will produce an error. Okay, now you know the basics, so I will show you some array methods. Let's first of all format this in a pretty way, and let's try some methods. So first of all, you have array, or let's say are like this. You have a begin and an end. These are iterators, and we will go through them in a minute. And then of course we will have array.size, and we have two useful ones, so array.front and array.back and array something I, or otherwise called index. So what does this right here mean? Well, if we see our array to be of, let's say, 4 elements, and let's say this is our array 5, 6, 9, 1, and we want to know what's on the second position. In programming, or in C++, we have such a thing called indexing. It's like accessing the number of elements in an array. If we access the 0th element, we'll have a 5. The first element, we'll have a 6. the second we have a 9, the third we'll have a 1. So it's like we start from 0 and go forward by 1. So if we want our index to be, let's suppose index would be equal to 1, and we pass an argument as array index, just like in our example, this would result, if our array is just like this array, this would result in giving us 6. So the result will be 6. Okay. The front gives us the 0th element, or if you like to call it the first, and the back will give us the last element. So I'll just comment to explain it better. Returns the first or the 0th, or let's say the first element in the array, and this returns the last element in the array, and this one here returns the element at the index, or let's say I, and I will just change I like here and give it like this. All right. So we will have also in array, we have also a get method. So array get I. This is the same as the previous one. So get array get I, like this one. The same as I, but if we get out of bounds, so for example, if we have an array like this of 3 elements, like 5, 6, and 3, and we know that the indexes are 0, 1, 2, and let's suppose we have an operation like ARR 3. What do you think it will get us? It will get us a random value. Random value. But we don't want that. If we go out of bounds, so out of bounds, we want to know that we went out of bounds and to do some checking. That's why in C++, in arrays, we have a get method which does exactly that. The getI method, if we do array get of 3, what do you think it will result? It will give us an error. So now we will know that we are out of bounds. Okay, let's go to next example. This is a little bit a more complex example, but I think you'll manage it. An array can be filled with values, so we have a fill method. So in the fill method, we just pass one value, and it's the value that we want to populate our array. So let's suppose we want to populate with 6s. All right, what does it mean? So let's suppose we have an array of 4 elements. 1, 2, 3, and 4. And let's suppose the first is 0, the second is 0, we have a 1, and we have a 4. And we call array.fill 6. After the array.fill with the value of 6, we will have the same array by meaning the same length, the array will not change the length of it, but all elements in the array will have 6s in it. So we have a 6, a 6, and a 6. So we'll fill the array with 6s. All right. And now I will show you the last method. But first of all, let's comment this so you can have a good note. Fills the array with the value that is passed to the method. So we also have an array swap method. So we swap two arrays. Let's suppose we have also an array of ints that must be the same size, 1e9 as the previous one, array 2, and let's initialize it 1, 2, 3, and alright, and we want to swap the values of array 1 and array 2, and this will do the job. So for example, if let's suppose our array 1 will have 3 elements, and also the array 2 will have 3 elements. It will have 1, 2, 3, 4, 5, 6. After the swap operation, so let's have it here, and this is the operation of swap. Okay, and after the operation, the first array, second array will look like this. So we swap the content, you'll have 4, 5, 6, 1, 2, 3. All right.